Okay, today a review day of some of the toughest trig we've had so far. First kind, I'm going to use tangent now. Remember, that changes something. Tangent of 4 theta is equal to 1. Okay, so let's just talk this through for a second. Tangent, kind of how that looks. Would you sketch tangent for just a second? Just normal tangent. Just want to make sure you get the big picture of what this looks like. You know what tangent looks like? What's really important is where those asymptotes are. I know you know it's kind of like one of those things, but do you know where the asymptotes are? Pi over 2 and negative pi over 2. Good. Now, in this case, they won't be there, though, will they? Because of what? What number messes that up? 4. And is that going to multiply everything by 4? No, multiply everything by 1/4. So then, what's this other side? What does that look like on a graph? Well, it's y equals this, so it's y equals that, so it's y equals 1. So it's a line running through like this. Do you get that there'll be a whole bunch of tangents like this that are running through it? And then there'll be a whole bunch of answers. So how many answers do you want? There's actually unlimited. You want all the answers up until it hits what? Good question. 2 pi? Yes, you're still going to want the answers through 2 pi. But what's special about tangent is you're not going to say plus 2 pi k, because tangent, you don't go over 2 pi to get the next answer. You go over 1 pi, because its period is 1 pi. So you will have to do this slightly different, because between tangents, normal tangent, you go over 1 pi to get to the next answer. 1 pi to get to the next answer. But this is not normal tangent because of that. All right. So I do a u substitution right off the bat and change this problem into tangent of u equals 1 and do circle trig to find the answer. And then I would, after that, switch the u back to 4 theta. All right. So that's a quick reminder of that kind. Now, bear with me. I know some of you are already working on this problem, but actually, I'm gonna let you continue. Go ahead. Work on that problem for a bit. In a moment, if you finish this one, look up at the board. There'll be another problem up here that's kind of like what you did yesterday, where it has a cosine of 2 theta in it. Just before I leave you, who's got that memorized that can help the other people? Cosine of 2 theta is actually... Got it memorized off the sheet yet? We used it last night. Cosine of 2 theta is, yes? Cosine squared minus sine squared. That's right. I'll write that up here just so you can use this as a bridge. You do need to know this yourself tomorrow. Cosine of 2 theta is cosine squared minus sine squared. All right, I'm going to pause for a minute while you process that first question. Tangent of 4 theta equals 1. There's multiple answers. Don't forget the plus 2 pi k thing is a little different when you're doing tangent. Pausing. Okay, how many of you done with that first one? Raise your hand if you think you are. I'm at about half. Okay, then I'm going to give you more time on that, but for those that are done, those half that are done, here's your other problem. Cosine of 2 theta, let me think, is equal to I'm going to pause for a second. Okay, I got the other problem I'd like you to try. And as much as you are not going to have a group for this problem, I still would like you to have somebody that you can check with today, because you're still in the learning phase here. So this is a tough one, the blue one. You'll have to use the real red fact here, that cosine of 2 theta is cosine squared minus sine squared. And being real with you, it's humanly possible that I have not set it up right. I have double checked it, and I really believe I did it right, but these are complicated to make. So if you think this isn't working, check with me early, and we'll make sure that some of the groups are making progress on it. Okay, try the blue one, and I'd like rows 1 and 2 to slide next to each other. Rows 3 and 4. And rows 5 and 6 slide next to each other, 6 inches apart. In your scenario, since you both are solos here, would you be willing to move up here, please, so that you guys can work together this hour? Okay, just checking to see if you were making progress on the blue one. Raise your hand if you feel like it's factoring, if you feel like it's working. All right, then here's what I intended for you to think. First of all, cosine of 2 theta can be replaced, and of course should be, with cosine squared theta minus sine squared theta. And then I have minus 2 equals negative 3 cosine theta. And then, generally, do you get that you're trying to get it all down to one function? Okay, so what's the one function that's different? Sine. So let's replace the sine squared with what? 1 minus cosine. Now that should have been standard operating procedure. You should know you get them all down to one function. Now, I might have messed up my whether or not it'll factor here. So let's find out. Cosine squared theta minus parentheses 1 minus cosine squared theta minus 2 equals negative 3 cosine theta. And I'm afraid now that I'm looking at it, I think I know where I made my mistake in the factoring part. Okay, so now I have cosine squared theta minus 1. I forgot about the minus 1. Yep. And then plus cosine squared theta minus 2 is equal to negative 3 cosine theta. Just double checking I distributed my negative properly. Okay, now my two cosine thetas can go together. Cosine squared theta, but there's 2 of them. And then, yep, right there, I forgot that negative 1 was going to be there. That should have been a negative 1. Sorry about that. So now I have negative 3 cosine theta, and then 2 cosine squared theta. And again, right there, if that had been a minus 2, it would have all worked out nice. So it didn't work out nice. You're right. But if you got it this far, minus 3 is equal to 0, then you were doing it right. How many of you got it that far? Okay, cool. So again, I told you ahead of time there was a chance that I had messed that negative up, and I did. So if I changed this in the original problem to a minus 1, then if you want to clean this all up, you can, or you can just start from the end. I'll show you in a moment. That would have been a minus 1. That would have gone with this other minus 1 and made a minus 2 right here. And then this should have been a minus 2 right here. Then, from there, I believe, double checking, nope. I would have to have this be positive. And I had it, oh, that actually should be positive. It was a negative 3 cosine here, so when I moved it to the other side, it would be positive 3 cosine. So I don't need to change anything else there. This now will factor. So again, I did make a mistake in the problem. I apologize, but start from here and see if you can factor that thing. And by factoring it, you'll be able to finish the deal. Your answers will be angles. And you'll have to do circle trig at the end to figure out those angles. Okay, if you're not done factoring that one and solving it, go ahead and finish. But now I'm going to go and just show the work, and you can always go back and watch this video if you want to. I'm going to show the work on how you'd solve the black one. Tangent of 4 theta equals 1. All right, first off, we let u equal 4 theta, so we have tangent of u equals 1. I like to always put that as 1 over 1. Now I'm going to get tangent is 1. Tangent is positive is what I'm thinking. All students take calc. Tangent is positive, so it can't be here and it can't be there. Therefore, I should add 2 answers. 1 here, TOA, opposite over adjacent, 1 root 2. And oh yeah, that's the 45-degree angle one. So if that's 45, I also would rather put that into radians, and so I'm going to use pi over 4. If that's pi over 4 to get to here, then my other triangle, which is down here, we use a whole bunch of pi over 4s. To get to here, that'd be 4 pi over 4. One more would make 5 pi over 4. I get pi over 4 and 5 pi over 4. But, boy, that was back when life was easy and I just had to do circle trick. So now, u equals this and u equals that. But since we did a u substitution, first of all, I'm going to pause for a second. Did you guys initially get pi over 4 and 5 pi over 4 on that first one? Yes? Okay, good. Then I'm going to show you how to finish it. If u is equal to pi over 4, then it's really 4 theta equals pi over 4 plus, and again, you don't do 2 pi k because the period on tangent is just pi. So it's pi k. You catch that? Normally you do a plus 2 pi k to go over a period, but the period of tangent's only pi, so you do plus pi k. Now, I'm going to multiply by 1/4 here, 1/4 here, and 1/4 here, and that gives me theta is pi over 16 plus pi over 4, which it'd be really nice if that was in 16ths, so I'm going to times by 4 over 4, and that'll make it 4/16. So here's my answers. Pi over 16 is one of them. I'm going to write them over here. Pi over 16, because that's if I plug in k equals 0 right here, then that right side wouldn't matter. So pi over 16 plus 4 pi over 16 would be 5 pi over 16. And let's see if I can do another one. Let's see if I can add another one. I'm going to put in a 2 here, 2 of those. So that would be 4 pi over 16. So it would be 8 pi over 16 plus another one is 9 pi over 16. Still less than 2 pi, so I could keep going. And I just add another 4 pi over 16, and that would make 13 pi over 16. Am I doing this right? I think so. And then I'm going to add in another one, because I'm still less than half of a pi. You know what I bet they would have done on the test if it was a tangent? Is they probably would have said all the answers between 0 and pi and said 0 and 2 pi, so there wouldn't be so darn many answers. Because otherwise, I'm going to have to keep on adding 4 pi over 16 over and over and over until I finally get enough. Did anybody do that and get like 16 answers for this thing? Is there 8? All right. So now I'm going to do the other one, which is 5 pi over 4. See, this one, I didn't ever tell you exactly when to stop. So I'm going to stop on that one right there. On this one, 5 pi over 4. Now I'm going to take 4 theta is equal to 5 pi over 4 plus pi k. And I'm going to multiply by 1/4 and 1/4 and 1/4. And that cancels, and so I have theta equals 5 pi over 16 plus 1/4 means, and I'm going to times by 4 over 4, and I get 4 pi over 16 again. And I'm going to keep adding 4 pi over 16 to that. So here's 5 pi over 16. Oh, that's this one. I'm repeating that one. Okay, cool. 5 pi over 16, and then I'm going to add another 4 pi over 16 makes 9 pi over 16. We already had that. And then I'm going to keep on adding another one, 4 pi over 16 more. I made the 13 pi over 16, add another 4 pi over 16 makes 13, 14, 17 pi over 16. And I can just keep on adding 4 pi over 16. So 21 pi over 16. And is there one more that'll fit in there? 25 pi over 16. Okay, 1, 2, this is a repeat answer. 1, 2, 3, 4, 5, 6, 7, maybe one more. I'm going to add another 4 pi over 16 is 29 pi over 16. Come on in. Put your pass there. Okay. All right. Whew. That was tougher than I thought it was going to be. This one. If you do a u substitution, you'd have 2u squared plus 3u. Did I write cosine twice right there? Minus 2 equals 0. Now I'm going to factor it. 2u here and a u there. And then what I hoped it would factor to is 2u minus 1 and u plus 2. Can anybody verify that that's what it factored to? Yes, yay. Okay, then I'm going to, remember, I'm still solving for u here, so I'm not done, but 2u is minus 1 equals 0, and u plus 2 equals 0, so u is negative 2, and solving this one, 2u is 1, so u is 1/2. But what is u really? U is really cosine. I should have written that here. Let u equal cosine. Then, this is cosine theta equals 1/2. Cosine theta equals negative 2. And this one, did anybody catch? Cosine can't go down to negative 2. You realize that one is, that's impossible? Think about the graph of cosine. What's the lowest it ever goes? Negative 1. And remember, it's a wave that goes back and forth. And the lowest it ever goes is negative 1, so it can't be negative 2. You could have beat your head against that one, but you would have never figured out the answer because there is no solution to that part. Okay? Then we're left with just this, which, oh, yay, it's just circle trig. All right. So, oh, students take cosine's positive here and here, so that's out and that's out. And 1/2, adjacent hypotenuse, 1, 2 square root of 3. What's across from the square root of 3 is a 60, also known as a pi over 3. And a whole bunch of pi over 3s. This would be 3 pi over 3, 4 pi over 3. The other one over here would be 5 pi over 3. Who had pi over 3 and 5 pi over 3? Whew. There we go. There's number 2. Next tough problem. Do you even remember inverse trig? I'll give you a relatively simple one. Inverse sine of negative root 3 over 2. Hint, your first step was always to rewrite this as just a normal circle trig question. Sine of theta equals, etc. But just remember that it actually is inverse trig, and therefore inverse sine's only allowed in 2 of the quadrants. So factor that in. Right off the bat. Quick reminder. Inverse cosine goes here to here. Inverse tangent goes here to here and can't touch because tangent has asymptotes on it. And last but not least, inverse sine, the one we're talking about, is only allowed from here to here, and it can touch because sine touches, doesn't have asymptotes. So inverse sine's only allowed in those quadrants on the right-hand side. Quadrant 1 and 4. So in quadrants 1 and 4 only, you would draw yourself a little picture. But wait, of those 2 quadrants, do you remember me saying that inverse trig only gives you one answer? If you're doing an inverse trig question, you're only going to get one answer for it. Why? Because if I rewrite this as sine of some angle equals negative root 3 over 2, the sine is negative only in one of these 2 spots. Sine is positive here, so it can't be there. And therefore, I am forced to be down in here. Go ahead and finish that problem off. See what you think the answer is. Okay, let's finish this one up. So, Sine is opposite of hypotenuse. Opposite is negative root 3. Hypotenuse is 2. This must be a 1. This must be a 60. But you don't really say 60. You actually say pi over 3. But this is a big moment in circle trig, or sorry, inverse trig. Do you remember that down here, this is considered negative pi over 2? You give answers that are negative when you're in that quadrant. Did you remember to give this as a negative answer? Here's the other way to say it. Your answers to inverse trig, you're only going to get one of them. It can be negative, and it can never be bigger than pi. So if you were tempted to give this answer of all the way around to here, which would be a whole bunch of pi over 3s, that would have been 5 pi over 3. 5 pi over 3 is wrong because you can't ever have an answer bigger than pi. Because remember, pi's the farthest that you can go. This is the dead zone. You can't go past pi. There you go. All right. So final answer to this one was negative 60 degrees, but I want it in radians. So negative pi over 3. Raise your hand if you actually had negative pi over 3. Awesome. Then, the only other kind I have to prepare you for tomorrow's test is, what if you have just an x? Like I don't tell you the sides. What if I give you that one of the sides is x? Then I can't ask you what the angle is. Somebody just asked me that a second ago. Like, how would you figure out what the angle is? You can't figure out the angle. So on a problem like this, we would say cosine of that. All right, so remember on this kind, you start on the inside. You draw a picture. You end up with a triangle. The triangle has sides. The triangle, if you get all 3 sides figured out, you don't need the angle. It's a completely separate question here. I'm preparing one because somebody asked about what if you don't know the sides in a triangle? What do you do then? I'll talk about that for a second, but what's more important right now is the red one. I know you have to know how to do that. I want to pause for a moment while you finish the red one. If you want to start the black one, go ahead, but finish the red one first. Okay. I'm running out of time, so I don't have time to let everybody finish. But if I'm doing an inverse sine question, the first thing I'm going to do is rule out some quadrants, because inverse sine's only allowed in these two here. So therefore, I'm going to cross off these guys. Then I'm going to rewrite this, and I remember telling you that whenever you have a variable, just do it in quadrant 1. Okay? So there's a variable. I can't tell if it's negative or not. Safest thing, all the functions will work here. Do your triangle in quadrant 1. Okay? Sine is opposite, hypotenuse. And then what's the other side? Back to this. Okay, we're back from the pause. This is the square root of x squared and 1 squared, but you subtract them. X squared minus 1. How many of you got the 3 sides all labeled properly? Cool, because from there, I've told you this since the beginning. Once you get a triangle drawn in the right quadrant with all the right sides, and if you can, all the right angles. We don't know what the angles are, so we can't do that part. Then I just do the cosine of it. Cosine's so easy. Once you get that drawn, it's easy. Cosine is adjacent, hypotenuse. So it is square root of x squared minus 1 over x. Okay, and then I was asked about this. What if what if they don't tell you sides that you're familiar with? Well, you can still do this. Sine of theta is equal to negative 1/4. You can still figure out where it is. Sine is SOHCAHTOA, right? So sine is opposite and hypotenuse. Is it possible to have a hypotenuse? Yep, I can draw a triangle for it. Next, sine is negative. All students take calc, can't be here, because sine is negative. And it was an inverse sine question. It says arc sine, right? So that tells me inverse signs only allowed, well, put it this way, no functions work here when you're working with inverses. So then I have to be here, and then I can label it, sine is opposite, hypotenuse, and yeah, you are down to a spot where you don't know this triangle. You don't know what angle it is. So how do you say the answer if you don't know what the angle is? Believe it or not, you can just leave your answer then as, you can do sine, cosine, or tangent. But we typically default back to the function that they all came from in the first place, which is sine. Okay, and so then, first of all, I'm going to figure out this side. 4 squared is 16, square root of 17. Good. If they had asked me for sine, cosine, or tangent, it would have been easier, because I could just say, oh, sine, 1 over root 17. Cosine, root 17 over 4. But if they don't ask me, if they just ask me for what is the angle here, you'd have to default back to, if I had a calculator, I would type this. Inverse sine of negative 1/4. But is that the only answer? In this problem, that's the only answer, and we'd be done. And yeah, I know, that's like writing the problem over again. But in the problems that we did before, like this one, where we get like a bajillion answers at the end, do you get these were not inverse trig questions? And so if you're asked to give the answer, you'd have to say plus 2 pi k at the end to signify that there are more answers. Okay, those were 4 good practice problems for your test for tomorrow. I would strongly recommend going back and doing problems that we skipped because their answer keys are there. There's lots of problems that we never did, but the answer keys are there for them. Do some practice problems tonight for your test tomorrow. It'll be great practice. Have a good day.